This is the afternoon of the 6th of November. Looks like Mac's Afterburner. Maybe he caught a hold of one of my videos that I posted. Airline pilot explains what actually might have happened to UPS 2976. It's amazing. He's on the same thing I'm on, so let's have a listen. Plays for 16 minutes.
Welcome to the video, everybody. This will be a recount of the newest information that's being released from the NTSB, the FAA, and some information about this crash and some updates on what's been going on. Flight 2976, that UPS crash, was an MD-11 cargo jet. It departed the runway at Louisville, Kentucky en route to Honolulu. The focus is on the engine now, the engine detachment. And in this video, I'll be doing a comparison to the 1979 American Airlines Flight 191 disaster, including the maintenance scandals that contributed to that disaster and the adaptations that were made to subsequent aircraft designs. That doesn't mean that's exactly what happened in this UPS 2976 crash, but we'll be looking at the different parallels between the two. We'll also dive into the technical specifics of these McDonnell Douglas tri-jets. They've got 3 different engines, from their pylons, the engine mounting systems, to the aerodynamic forces that happen when an aircraft is taking off like this. We'll explore some potential failure modes like fatigue cracking and torque mismatches that could create tragedies like this. So some fresh insights. The NTSB and the FAA are talking about that engine breakaway. The NTSB's preliminary findings indicate the left wing engine, the number 1 engine, which is a General Electric CF6 80C2, that's a high bypass turbofan. It delivers over 60,000 pounds of thrust. It fully detached during the takeoff roll, separating at the pylon wing interface. Eyewitnesses and videos and flight data show the plane pitches left. The wings are uneven due to that sudden loss of thrust and that asymmetric drag from the missing nacelle and the missing engine, and then it stalled and slammed into the ground just beyond the runway end and it erupted into a fireball. It just cleared the airport fence and smashed into terrain and buildings. The FAA's on-scene team confirmed the airport's partial closure, with taxiways still cordoned off as they sift through the wreckage that spread over nearly half of a mile. So this was an MD-11 freighter. It was registered as number N259UP. It was a stretched derivative of the DC-10 with a 206-foot wingspan and maximum takeoff weight that exceeds 650,000 pounds. It was loaded for a trans-Pacific haul with cargo secured in its reinforced main decks. Takeoff was around 5:15 p.m. local time. It was clear skies and no significant weather was reported during the time of the crash. So there's no determination yet on why exactly that engine detached, but some possible causes include pylon failure from high cycle fatigue in the aluminum alloy fitting, where repeated pressurization cycles can lead to micro cracks, very tiny cracks that can propagate under the hard loads of repeated flying of that aircraft. Mounting hardware issues like loose or corroded shear pins, or even a resonance-induced vibration mismatch could have caused stress fatigue during the high-power spool-ups that these engines go through during every flight. But
The FAA needs to ground every one of these airplanes until they can inspect all those pylons. If they don't, this can happen again.
the FAA obviously is emphasizing patience, and the NTSB is emphasizing patience as well. There's no official report yet, and again, I'm just a pilot on YouTube, and UPS, that company, is cooperating fully. They're providing maintenance logs on the aircraft, including recent testings for the pylon and the engine itself, and any of the critical components that go into keeping that engine on the aircraft. But now let's talk about American Airlines 191. There is a scandal behind that accident. So because of cost cutting and deadly shortcuts on May 25th, 1979, at O'Hare International Airport in Chicago, American Airlines 191, that was a DC-10 that was bound for Los Angeles. It lifted off with 271 people on board. That's a wide-body tri-jet, and it's powered by 3 General Electric CF6 6D engines. Each of those are beasts. They produce 40,000 pounds of thrust. 31 seconds later, after the takeoff roll, the left engine and its pylon ripped free of the aircraft and cartwheeled over the wing at over 300 feet per minute. The plane banked hard to the left and then basically did a cartwheel towards the ground, and it killed all on board, plus +2 on the ground. This remains one of the single most deadliest aircraft crashes in US history. But one of the differences that I saw when looking at the footage with the UPS 2976, it looks like that left engine detachment, the debris coming from that actually caused a compressor stall in the number 2 tail-mounted engine. In the American Airlines 191, that didn't seem to be the case. There were other issues that we'll get to here in a second that seemed to cause the crash for American Airlines 191, even though the engine detachment seemed similar. But the NTSB determined that the cause of the American Airlines 191 involved maintenance shortcuts that were driven by cost cutting from the airlines. In the post-oil crisis era, American Airlines abandoned the factory manual's engine removal process, which used a crane for the engine alone to avoid stressing the pylon's stainless steel fittings that kept that engine firmly seated onto the wing. And instead, they used a forklift to remove the entire engine pylon assembly for faster turnarounds and lower costs, slashing maintenance from 68 to 26 man hours. On the aircraft involved in American Airlines 191, 2 months earlier, a forklift slipped during reinstallation and it damaged a pylon by slamming into the wing's underbelly at the forward bulkhead. This introduced a half-inch misalignment and cracks in the left clevis pinholes, but inspections missed them because the shortcuts bypassed torque checks on the pylon's forward and aft bulkhead fittings. Critical 1-inch diameter pins rated for 100,000-pound shear loads. Those are very crucial parts of that structure to keep the wing on board, and just one oversight like that.
To keep the wing on board? You mean to keep the engine on board?
Helped cause that tragic disaster. And because that engine wasn't seated properly, and then it was flown multiple times for that American Airlines 191, it created stress fractures throughout that entire engine to wing assembly, because you can go up to 2 G's or so in an airliner. That's not uncommon in certain situations, even though typically you remain below that. But even those low G loads with continuously cycling over metal pieces that aren't fitted properly, it basically caused those stress cracks, and they weren't maintained properly and they weren't inspected properly. Congressional hearings criticized American Airlines for prioritizing efficiency over safety with rush shifts and a culture of inadequate checks. They relied on visual inspections instead of eddy current testing for subsurface flaws. So actually getting technology in there that can see what's going on inside the metal is hugely important, and it looked like that was skipped at the time. McDonnell Douglas faced scrutiny for unclear manuals that facilitated the method, and the FAA acknowledged certification lapses without sufficient testing of the forklift procedure under that full load of that entire engine. And then post-crash inspections revealed 9 other DC-10s with similar pylon cracks from...
See, there was 9 other DC-10s with similar pylon cracks. That's why they have to inspect all of these MD-11s. Now, they need to ground them and inspect them.
The procedure, often hidden until dye-penetrating tests expose them. Those are maximally invasive tests to see what's actually going on with the metal. So following American Airlines 191, the FAA grounded all 273 US DC-10s for weeks, mandating X-ray inspections of the pylon fittings, redesigning...
They need to do the exact same thing now on the MD-11s. This exact same procedure has to be adhered to.
Pylons with stronger aluminum that was rated for 150% overload, which is way more than what they had before. And then they mandated a return to separate engine pylon removals using specialized rigs to ensure alignment within 0.01 inches. McDonnell Douglas added redundant shear pins, double row configurations with fail-safe fusing, and improved load distribution via spherical bearings that reduced bending moments by 40%. So again, they really got in there and made sure that this metal was seated properly. And to address the slat issue, where the detaching engine severed hydraulic lines at 3,000 psi, and that retracted the left wing's leading edge slats and caused asymmetric lift with a 15-degree roll rate, they implemented backup hydraulic circuits with electrically driven pumps and slat locks using solenoid actuated pins to maintain extension up to 250 knots. So even if an engine detached, those slats wouldn't retract.
Those engines are designed to go over the wing, but I guess part of that other engine went into the tail engine, which also I think flamed out.
That was the fix that they made to the DC-10s after that American Airlines 191 incident. And then the MD-11, which was introduced in 1990 as the DC-10 successor, incorporated these lessons with a refined airframe, a 192-foot fuselage stretch for better stability, but retaining the tri-jet layout with those CF6 or PW4000 engines up to 93,000 pounds of thrust. Pylon structures featured enhanced forged titanium and fittings that were resistant to fatigue, with crack-arresting doublers and vibration isolators tuned to dampen frequencies above 50 hertz during takeoff. Because during an airliner takeoff, all of you out there that have taken off on an airliner, you could just see everything shaking inside of that aircraft, and you have to make sure that everything is staying seated properly even during those massive amounts of vibrations. But the MD-11 boasts 3 independent hydraulic systems that have 3,000 psi each, so any one of those are sufficient for the full flight control actuation. And they also added an electromechanical slat backups with position sensors that feed the fly-by-wire elements for automatic asymmetry compensation. So as soon as asymmetry is noticed, the flight control system uses automation to try to account for that asymmetry. And then I know this is getting very technical, but I think it's important that we talk about the updates that were done to the MD-11. Engine mounts include elastomeric dampers to absorb gyroscopic precession torques. So again, all those different vibrations. And the freighter variants, like UPS's, add reinforced floors with 1.5G cargo tie downs to minimize any type of flex that could be induced by pylon stress. So all those adaptations were done to this mishap aircraft for UPS 2976. So these changes improved safety margins, with MD-11s accumulating over 10 million hours and a dispatch reliability above 99%. However, the UPS incident suggests vulnerabilities may persist if those pylons have integrity issues or if inspections falter, perhaps from extended service life that are beyond 75,000 cycles, 75,000 takeoffs and landings. And with that many cycles on these aircraft, maybe it's time that these maintenance procedures, the inspections, are updated to account for an airframe that's as old as these MD-11s are. So let's talk about some parallels and some pivots. So what makes these crashes similar and what makes them different? So both incidents involve McDonnell Douglas tri-jets with left engine detachments during takeoff, which is just super rare. In each, they lost thrust, and asymmetric drag caused that violent left yaw, leading to a stall and loss of control. American Airline 191's pylon severed controls via the hydraulic ruptures, and that dropped pressure to 0. Preliminary UPS data indicates a similar roll type stall as that wing starts to dip down. That left wing starts to dip down, as we've seen in a lot of the bystander footage. And that was potentially complicated by the tail engine ingesting pylon debris. And so that's the difference. The UPS, it looks like they ingested debris into their tail engine, whereas in the American Airlines incident, there wasn't any reports of that. But when you ingest debris into that tail engine, it's going to cause some sort of a compressor stall, and that's what we saw during that takeoff footage. And both of these occurred past V1 decision speed likely. So around 150 knots for the DC-10 and a little faster, around 160 knots for the UPS MD-11, with pilots committed at takeoff at that point, and then you're facing a stall that you really can't correct from. I'm sure the pilots in both of these scenarios fought to the very end, but unable to correct that yaw and that roll to the left, you're really out of options, and they kept fighting. But some of the key differences include aircraft type. So the DC-10 had a simpler 2 hydraulic system setup compared to the MD-11's triple redundancy. And with American Airlines 191, it was clear that maintenance was a factor there due to the fact that their inspections were lacking and they were choosing efficiency over safety. But could metal fatigue have played a part in both of these? So when it comes to the MD-11, maybe the amount of cycles and the massive amount of times that it was flown meant that there needed to be updated inspections or even thermal or x-ray inspections that needed to happen more often. But with the DC-10 American Airlines 191, that slat retraction was a decisive factor in that created a 20% lift asymmetry. But with the MD-11, redundancy should have provided 10 to 15 seconds of recovery time via differential thrust from the centerline engine, but the stall was rapid, possibly from the secondary wing damage. So the MD-11, with its updates, and its triple redundancy to the hydraulic system, likely it's not going to have that same situation where that slat immediately retracts on the left wing and causes that stall. We can see that there's a difference there with that compressor stall happening on the tail of the MD-11 as opposed to the report from the DC-10 where there wasn't any report of that compressor stall. But videos of both events show comparable sequences, wing dip from adverse yaw. The MD-11's adaptions post that AA-191 crash underscores advancements and no reported total hydraulic failure currently on that UPS 2976. So the NTSB, that full investigation into UPS 2976 will likely take 12 to 18 months. They'll examine the pylon for fractures, any patterns that they can see with metal fatigue. They'll be doing electron microscoping, basically getting in to the very fine details of what's going on with that metal to try to reveal if anything irregular is going on with that metal or any type of cracking from any overloads or overuse. And likely there'll be many more maintenance updates, inspections, and updated requirements from this situation. But again, it remains to be seen, and there'll be a full investigation by the NTSB.
Sean Duffy needs to ground all these MD-11s until those pylons are all inspected. They found 9 on that 97 crash. They found 9 that had cracked pylons. That's what I said. Caused the problem. I said that this morning. I'll attach the link. Look at it. Let me know what you think. Pass it along, and thanks for listening.